Hi. In our previous lesson, we mastered the basics of representing data using matrices. Now, it's time to put those organized numbers to work. Today, we're diving into the essential matrix operations: addition, subtraction, and scalar multiplication. We'll break down the core rules for each operation and solve 3 real-world business scenarios, ensuring you're ready to tackle any matrix problem on your exam. Let's get started. Your first mission, should you choose to accept it, involves fusing 2 datasets. We have matrix A, representing laptop and phone sales at store 1, and matrix B for store 2. Your task is to find the combined sales matrix, A plus B. Can you do it? The fundamental rule of matrix addition is that the matrices must have the exact same dimensions. Both A and B are 2 by 3 matrices, so we're clear for takeoff. To find the sum, we add the corresponding elements. The element in row 1, column 1 of A, which is 12, is added to the element in row 1, column 1 of B, which is 3, giving us 15. We repeat this process for every position. 5 plus 7 is 12. 8 plus 10 is 18. Moving to the second row, 20 plus 4 is 24, 15 plus 11 is 26, and 9 plus 18 is 27. Mission complete. But what if we tried to add matrix A to matrix D, which is a 2 by 2 matrix? The operation fails. Why? Because the dimensions don't match. The element in row 1, column 3 of A has no corresponding element in D to add to. Here's an IB exam tip. Always state the dimensions of your matrices before adding or subtracting. If they don't match, simply write, "The operation is undefined because the matrices have different dimensions." This shows the examiner you understand the core concept. A new challenge has arrived. Matrix S shows a warehouse's starting inventory of components, and matrix E shows what was left at the end of the month. Your objective is to find the net sales matrix N by calculating S minus E. Just like addition, subtraction requires the matrices to have identical dimensions. Both S and E are 3 by 2 matrices, so the operation is valid. The process is identical. We subtract corresponding elements. For the first element, we take 150 from S and subtract 45 from E, which gives us 105. Next, 80 minus 30 equals 50. In the second row, 200 minus 82 is 118, and 120 minus 55 is 65. Finally, 75 minus 15 is 60, and 90 minus 25 is 65. There's our net sales matrix. And what if we tried to subtract a 2 by 2 matrix F from our 3 by 2 matrix S? The operation is undefined. The dimensions do not match, so the audit cannot be completed. IB tip for paper 2. While you can use your GDC for these calculations to save time, be careful with data entry. A single wrong number will cascade through your answer. Always do a quick visual check of the matrices on your calculator screen before hitting enter. Here is your final task. Matrix M represents the manufacturing costs for several products. Due to market changes, all costs are increasing by a flat 20%. You need to generate the new cost matrix by multiplying matrix M by a scalar. What is the result? A 20% increase means we multiply by 1.2. This value, 1.2, is our scalar. Scalar multiplication is straightforward. You multiply every single element inside the matrix by the scalar value. There are no dimensions restrictions for this operation. So we take 1.2 and distribute it. 1.2 times 50 is 60. 1.2 times 120 is 144. 1.2 times 85 is 102. 1.2 times 30 is 36. And for the last row, 1.2 times 210 is 252, and 1.2 times 75 is 90. And there we have it, our adjusted cost matrix. IA suggestion. This is a powerful tool for your IA. If you're modeling any system that scales uniformly, like applying an interest rate to a series of investments, or scaling a geometric shape represented by coordinate matrices, scalar multiplication is the perfect mathematical concept to apply and demonstrate a deep understanding. We've successfully added, subtracted, and scaled data using the power of matrices. You now know the three fundamental matrix operations, and crucially, when they are defined based on the dimensions. This is the foundation for solving complex linear equations and tackling real-world problems in business, engineering, and computer graphics. In our next video, we'll cover the most powerful operation of all, matrix multiplication. Don't miss it. If this video helped you conquer matrix operations, please hit the like button, subscribe for more IB Math tutorials, and leave a comment below telling us which matrix operation you found easiest. Keep exploring, and we'll see you in the next lesson.